This podcast is about substance abuse and addiction. In 2014, the National Survey of Drug Use and Health looked at people in the US who were 12 or older and found that in 2014, just over 10% had actually used illicit drugs at least once in their life. Marijuana was the most common drug. 82% of drug users were using this illicitly. And about 52.7% had used alcohol within the last month. So, of course, alcohol is legal, and even in some states, marijuana is legal now too. And about 23% of people were binge alcohol users. So what's a binge user is somebody who has 5 or more drinks on one occasion. So that's a pretty high percentage. However, only 8.1% of people surveyed met the criteria for substance use disorder. So even though people use drugs fairly frequently, you can see marijuana is used a lot, alcohol particularly is used a lot, but only 8.1% of people go on to develop a substance use disorder. So it's not everybody, clearly. So what are the criteria for having substance use disorder? According to the DSM-5, there are multiple different criteria that can be used, and they come under different headings. So diminished control, basically you might want to reduce your use of the drug, but you can't. And so you spend a lot of your time actually using, acquiring, or recovering from drug use. And under this heading is craving. So we'll talk about the biological mechanisms of craving and diminished control. There's often diminished social functioning, so you're not able to see your commitments through at work or at school or at home. And you continue using the drug even though you have these social problems. And you may then also have reduced activities, either socially or with your hobbies or at work. So maybe calling in sick more frequently, something like that. Hazardous use. So many drugs are hazardous. They can affect your health, and people continue to use them despite these hazards. And sometimes people have physical or psychological changes as a result of the drugs, and still they continue to use them. The fourth category is drug action, and again we're going to be talking more about the physiological mechanisms behind these two different criteria. One is experiencing tolerance. So tolerance is when you need a greater amount of the drug to get the same effect. So many people take drugs because they make them feel euphoric. And so you need more and more of the drug to actually get that feeling of euphoria. The other drug action criteria is that somebody might experience withdrawal symptoms. So these are negative symptoms. They usually make you feel really very sick. And these occur when you're trying to quit the drug. So as you're withdrawing from the drug, you experience these symptoms. So according to the DSM-5, if you have 2 to 3 of any of these criteria, then you have mild substance use disorder. If you have 4 to 5 of these items, then you have moderate substance use disorder. And if you have more than 6, then you have severe substance use disorder. So let's think about what's happening in the brain to somebody who is suffering from substance use disorder. Why is it that some drugs are particularly addictive? Well, to answer this question, we're going to go back and think about learning. We talked about reinforcement learning when we talked about learning and memory. And one of the things that we talked about was that if you do something that feels good, then you get dopamine release in the nucleus accumbens, and it makes it more likely that you're going to do that behavior again. Right? So these are rewarding behaviors, and we have natural reinforcing behaviors such as eating when we're hungry. That produces dopamine release in the nucleus accumbens, or having sex produces dopamine release in the nucleus accumbens. And just to remind you, here's the nucleus accumbens here. It's in the forebrain. And drugs of abuse, part of their addictive quality is because they too produce dopamine release in the nucleus accumbens. They probably also produce norepinephrine release in the same area. So that's what makes it so rewarding. However, the reason why drugs of abuse are more addictive than food, typically, and sex, at least for most people, is that they produce a very rapid release of dopamine, and they produce a much greater release of dopamine than natural reinforcers like food and sex. Right? So drugs of abuse produce the same kind of dopamine release, but it's much more rapid, and it's much greater in terms of the amount of dopamine that's present in the synapses. Okay, so when we get dopamine release in a certain part of the nucleus accumbens, we get this feeling of pleasure, right? So we like something, it feels good, and that's due to activation of a relatively small part of the nucleus accumbens, right? So neurons in a relatively small part of the nucleus accumbens. And at first, when a drug addict derives pleasure from a drug, they don't need very much of it to get that pleasurable experience. They get a quick rush of dopamine soon after taking the drug, and it feels really good. Right? So this is the liking part, if you like, of the nucleus accumbens. But what happens over time is that this part of the nucleus accumbens develops what we call tolerance. And it becomes more difficult to get this feeling of liking. There's another part of the nucleus accumbens that is related to wanting or craving. And this is what causes people to seek out the drug, or if it's food or sex, to seek out that too. And this is a much larger part of the nucleus accumbens. So you get dopamine release from both parts of the nucleus accumbens, but the activation in these areas changes over time. So over time, the drug doesn't produce pleasure, but the addict still is motivated to obtain the drug. And the reason for that is that the neurons in the small part of the nucleus accumbens that are related to liking become more tolerant. That means that they change, and you need more of the drug to produce the feeling of pleasure. On the other hand, the neurons in this larger part of the nucleus accumbens, which are related to wanting, they also undergo changes, but they become more sensitive to the drug. So they don't need very much of the drug in order to produce this strong wanting response. And in fact, you don't even need to have the drug to have the strong wanting response. You can just have a cue, something that reminds you of the drug. So it could be the neighborhood where you buy your drugs. It could be the drug paraphernalia that you use. Something about the drug, or something about the cue that reminds you about the drug, produces this really strong craving, right? And that's because of sensitization in this large part of the nucleus accumbens that makes us want or crave the drug. So we can begin to see why there's these feelings of diminished control, where people crave the substance a lot, and these changes in the brain that are occurring that mean that you need more of the drug in order for it to have an effect, right? So experiencing tolerance under drug action here, and also these very strong cravings that may diminish your ability to function properly in the world. So all drugs of abuse are going to have an effect on the synapses of the neurons. And we have different classes of drugs. And just here are just a few. We haven't included alcohol here. It's going to be on an upcoming slide. But here we've got various types of drugs, and you can see their main behavioral effects. And this middle column, and then where they act on the synapses. So if we look, we can see, we look at stimulant drugs, here, we can see all of these are affecting dopamine. This is their main synaptic effect. All of the drugs here are going to affect dopamine in some way, but it may be through a secondary pathway. So amphetamines are basically going to make you feel alert, excited, generally euphoric. You don't feel tired anymore. So you feel stimulated, hence the name stimulant. You can see amphetamines block the reuptake of dopamine, as well as other neurotransmitters. So the dopamine stays longer in the synapse. Cocaine has a very rapid action. That's one of the reasons why it's one of the more addictive kinds of drugs. It also blocks the reuptake of dopamine. And the same for Ritalin. Ritalin is much less addictive than amphetamines and cocaine because it has a slower action. And then ecstasy, it's both a stimulant and a hallucinogen. So the euphoria comes from the dopamine release, but also the serotonin release is related to the hallucinations. Nicotine has mostly stimulant effects, and it also increases dopamine release in the nucleus accumbens by stimulating the nicotinic acetylcholine receptors. right? So again, this is a little bit of a less direct pathway. And then opiates, like morphine and heroin, they tend to make people feel very relaxed and feel less pain. And they stimulate the endorphin receptors that are related to pain in various parts of our brain. And again, there's a secondary increase of dopamine release in the nucleus accumbens. Cannabinoids like marijuana are going to generally make you feel good. They might produce some altered sensory experiences, including decreased pain and nausea, which is one of the reasons why they're used medically, and increased appetite. And although cannabinoids are thought to be less addictive than these other kinds of drugs, they do still produce dopamine release in the nucleus accumbens. And they're thought to work in such a way that they're affecting autoreceptors on the presynaptic cells, so that are regulating the amount of dopamine release into the nucleus accumbens. And then we already mentioned ecstasy produces hallucinations. Other kinds of hallucinogens also stimulate serotonin receptors. Okay, so drugs of abuse can have many different types of effect in the synapse, but they do all work in the synapses in the brain. So I just want to introduce a few terms that we use to describe different types of drugs. Agonists are drugs that mimic the effects of a neurotransmitter. So we've said that all drugs of abuse actually produce dopamine release. So we could say that they're all dopamine agonists because they're having a similar effect to dopamine. A drug that's an antagonist would have the opposite effect to that of the neurotransmitter, right? So if, for example, if you had a GABA antagonist, we know that GABA has an inhibitory effect, so a GABA antagonist would have an excitatory effect. We can also describe drugs in terms of how easily they bind to a receptor. So if you remember that analogy we had where the neurotransmitter is kind of like the key and the receptor is like the lock. And we know for a neurotransmitter to work, then the key has to go into the lock and it has to turn, right? So we can think about drugs in a similar way. So a drug may have a similar shape to a neurotransmitter, and so then it would maybe have a high affinity for a receptor, which means that it binds very easily to the receptor, or if you like, the key goes into the lock very easily. However, whether or not it actually activates the receptor depends on its efficacy, right? So drugs with high efficacy activate the receptor easily. If you like, the key turns the lock. So it's possible to have a drug that has high affinity but low efficacy, and it might actually work in an antagonistic way, right? Because it's blocking the receptor and stopping the neurotransmitter from binding. Another mechanism that we mentioned at the beginning when we were talking about the different criteria for substance use disorder was withdrawal. So when somebody tries to stop using a drug, they may experience very severe withdrawal symptoms, and it makes them feel very sick. And this is because the synapses of the brain have changed, so they expect the drug. And then when they don't get stimulated, you get the opposite effects that the drug would actually produce. So in terms of opiates, that often makes people feel anxious. They may sweat a lot, and they may vomit and have diarrhea. In terms of alcohol withdrawal, people feel irritable, feel very tired. They might start shaking, sweating, nausea, and very extreme withdrawal symptoms might include convulsions, fever, hallucinations, and even cardiovascular problems. So if an addict starts to use a drug during this withdrawal period, then the drug itself provides relief from the withdrawal symptoms. And so they're more likely to do it again, right? So negative reinforcement, taking away something that doesn't feel good, makes it more likely that you will engage in that behavior again. And the suggestion is that this then can lead to craving the drug during other stressful situations when you're feeling kind of not good, maybe you're feeling anxious, maybe you're having some of these symptoms that you experience when you're withdrawing from the drug, and you know that taking the drug makes you feel better, and therefore you might crave the drug just when you're feeling stressed in general. So I'm going to spend the rest of the podcast mostly concentrating on alcohol, which is a legal drug, and how it works, and what are some of the factors that make it more likely that some people abuse alcohol than others. Okay, so first of all, what does alcohol do? In terms of the synapses, it decreases glutamate release and it increases GABA release. So just to remind you that glutamate is excitatory and GABA is inhibitory. And so perhaps it's not surprising that when you have small amounts of alcohol, you generally feel more relaxed, less anxious, you might feel a little sleepy, and you're less inhibited, and so not surprisingly, you might not always exercise the best judgment. In higher doses, it leads to slurred speech, difficulties with fine and sometimes gross motor skills. You're slower, you don't react as quickly, and you become very sleepy. At very highest doses, which you may experience amnesia, you may have a blackout, and you have no memory of what happened. You might experience vomiting, irregular breathing, and alcohol poisoning can actually lead to death. Alcohol tends to affect sleep, and so it suppresses REM sleep. And if you remember, REM sleep, like non-REM sleep, is important for learning and memory. So people who drink excessively may have difficulties with memory in general. Okay, so let's have a little look at why it might be that some people are more prone to alcoholism than others. There's basically two types of alcoholism. Type 1, and this usually occurs after the age of about 25. It affects men and women equally, and it has a gradual onset. So people kind of grow into their alcoholism, if you like. And that doesn't have a particularly strong genetic influence to it. The type 2, however, which mostly affects men, has a stronger genetic influence, and it tends to affect people at a slightly younger age. And evidence for the genetic component here comes from a series of studies of men under the age of 25 who had alcoholic fathers. So they were not actually alcoholic, but when they were exposed to alcohol, they reported needing more alcohol to feel drunk than people who did not have alcoholic fathers. So in other words, that they were more tolerant already to the effects of alcohol. And they also reported feeling less stressed when drinking alcohol compared to control participants, i.e. people that didn't have alcoholic fathers. So it seems to be something about the way that alcohol affects people who have type 2 alcoholism in their families that makes them more susceptible to actually abusing alcohol. They need to have more to feel drunk, and they feel the benefits of less stress more than others. So there isn't really a single gene that makes you more prone to being an alcoholic, but there's a combination of different genes, and different gene candidates have been proposed. So one suggestion is that there may be understimulation of the nucleus accumbens. So there are different types of dopamine receptors in our brains, or at least 5 different types. And it's been suggested that in people who become addicted to, particularly to alcohol, have less sensitive D4 receptors. So that means that they maybe don't feel the same pleasure as other people do when the nucleus accumbens is actually stimulated. And this is due to a long form of the gene. Another suggestion, which is a similar kind of line, is that maybe their dopamine receptors are understimulated, or there's less dopamine release in the nucleus accumbens because they have a more active form of an enzyme that breaks down dopamine, the COMT enzyme. And so if you have a more active form of the enzyme, you have less dopamine in the nucleus accumbens. So perhaps what you need is more stimulation in order to get the same effects. Environmental influences are also important. So it's been shown that prenatal exposure to alcohol increases the likelihood of alcoholism. So if somebody, actually a mother, drinks while she's pregnant, it increases the likelihood that their child will later in life become an alcoholic. And then, as always, there's the interaction between genes and environment. So another kind of gene can determine the sensitivity of your GABA receptors. Remember, alcohol increases the activity of GABA, so it makes it more likely to activate these GABA receptors. And if you have a less sensitive form of GABA receptors, so less likely to have inhibitory activity in your brain, the more impulsive you're likely to be. And it depends on how that impulsivity has been handled during your life. So if you have a very stable parental environment, a family environment, where your parents help to direct that energy somewhere and help to work with you over becoming less impulsive over time, then you're less likely to develop antisocial kinds of behaviors and addictive behaviors as you grow older. One drug that's been used with some success in treating alcoholism is a drug called antabuse. And in order to understand how antabuse works, we need to think about how alcohol is metabolized in our bodies in general. So when we consume alcohol, it's broken down by enzymes in our liver to a substance called acetaldehyde. And acetaldehyde is toxic. So we have another enzyme, which is called acetaldehyde dehydrogenase, bit of a mouthful, but that's the enzyme that breaks down this substance into a non-toxic substance, acetic acid. And then acetic acid can be used by the body for energy. Right, so this enzyme here is really essential in order to stop the buildup of this toxic acetaldehyde. Now, some people have a gene that means that they don't have very much of this enzyme, or they don't have this enzyme at all. So whenever they drink alcohol, they have a buildup of acetaldehyde, which makes them feel sick. And actually about a third of the people in China and in Japan actually have this genetic variation. And it's been suggested that that's why alcoholism is relatively low in incidence in those two countries. Okay, so what this drug does is it uses this mechanism, and it actually works on this enzyme, prevents this enzyme from working, and so it has an effect very similar to those who have this genetic variation where the enzyme doesn't work. Right, so the drug actually stops the metabolism, this step here, by antagonizing the effect of this enzyme. And as I said, you get a buildup of acetaldehyde, and that makes you feel nauseous, gives you a headache, stomach pain whenever you drink alcohol. So in order for this to work, somebody has to actually take the antabuse. And so it works well if somebody's compliant, and it doesn't work if somebody's not compliant. So if somebody's experiencing very strong cravings, they may decide not to take the drug, and then of course it doesn't have an effect. Another drug that works in a slightly different way is called Revia, and Revia is an opiate receptor antagonist. So opiate receptors, when they're stimulated, we feel pleasure. And so if you antagonize that activation, it reduces the pleasurable effects of alcohol. And again, as with the antabuse, it depends on compliance. So if somebody is really strongly motivated to stop drinking, they may be quite compliant and take the drugs. And if they're not, then it's not going to have very much of an effect. I'm just going to finish up with talking a little bit about opiate abuse. And some medications that have used, or at least one medication that's used to try and treat people that have opiate abuse issues. So a drug that's been used for many years now is methadone. And methadone is used to treat opiate addiction, such as heroin or morphine addiction. And it works in a very similar way to heroin and morphine. So it's an opiate agonist. However, it's not injected, it's taken orally, and so it has a slower effect. And if you remember, the faster the drug gets into the system and causes the dopamine release, the bigger the high you have and the more addictive the drug is. So with methadone, you have less of a high than you would with heroin or other opiates like morphine, and you have less withdrawal symptoms. And so even though it doesn't take away the addiction, it helps to satisfy the craving, and for somebody to be able to treat that craving in a safer way.